Okay, so welcome you guys. So this is my new YouTube channel. So here I'm going to talk about mostly about tech related stuff. So kind of like to have as the first video, just I'm going to go through lead code problem. So I'm going to do this for the next I probably next 2-3 months until we complete at least 50 lead code problems. So in this problem, this is a very easy one. So in this problem, it is called two-sum problem. So what we have to do here is they say given an array of integer nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can retain the answer in the code. So what we have to do here is they say there is a given array of integers and a target integer. So we need to check what numbers in the array add up to the given target number. So if we take this first example, array we have is 2, 7, 11, and 15. And the target number is 9, and the output is 0 and 1. Because nums 0 is 2, and nums 1 is 7, and 2 plus 7 is 9. And they also say there is only exactly one solution. So if we move to second example, uh, and also they say you may not use the same element twice. You can't use the same element twice. So since there is only one solution, that won't happen anyway. So in the second example, we have 3, 2, and 4, and the target number is 6. In this case, output is 1 and 2 because the 2 plus 4 is 6. Index of 2 is 1 and index of 4 is 2, and the output is 1 and 2. In the third example, we have 3, comma 3, and target number is 6, and 3 plus 3 is 6, and the indices are 0 and 1. So let's discuss this problem first, and then uh, come to the code next.
Okay, so here we have a given number array. So which is the first one is 2, 7, 11, and 15. And there is another target number. In this case, it's 9. So what we have to do here is we have to find the indexes of the two numbers that adds up to the given target number. So also they say there is only one solution, exactly one solution. So in this case, the output should be 0 and 1 because in this array only 2 plus 7 adds up to 9. So index of 2 is 0 and the index of 7 is 1. So there are a couple of ways we can solve this. So I will show you two basic methods that we can solve this one. So first one is really easy. The first method that we are going to try is we call it brute force method. So what we are going to do in the brute force method is we take each of these numbers and we check whether this number and the any of the rest of the numbers adds up to the given target number. So let's say if we take 2 and then we check whether 2 plus 7 equals to 9 or 2 plus 11 equals to 9 or 2 plus 15 equals to 9. So if any of those numbers adds up to the given target number, then we just return the indexes of the index of the number that we took and the index of the other number. So that this is really easy. This is what we are going to do in the brute force method. So let's say none of these numbers adds up to 9, then we move to the next number. Then we take 7, then we check again. We check whether 7 plus 2 equals 9, or whether 7 plus 11 equals 9, or whether 7 plus 15 equals 9. So again, let's say it doesn't have the answer as well, then we move to 11. Then we move to 11 and check whether the 11 plus 2 is 9, or whether the 11 plus 11 plus 7 is 9, or whether the 11 plus 15 is 9. So if that doesn't work as well, then we move to 15. So that's the brute force method. So here you can figure out we need two loops. So first loop is to iterate through these main numbers. So we have to iterate through each of these numbers. So that's one of the loops we need. And the other loop that we need is in each of those iteration, again we need to loop through the rest of the numbers in this array. So then we need two loops. One loop to walk through the main number, and the loop inside that to iterate through the rest of the numbers. So if we write a pseudocode for this, we need one loop to walk through the so it starts from the first number and go all the way to the last number one by one. So that's why I is 0 and I plus plus and I less than the length of the array. So n means n equals the length of the array. So inside this loop, we need another loop. So let's say we take j for that loop. J equals 0, j less than the length of the array, and j is j plus plus as well. So j plus plus means j iterates one by one. So what we need to check is I and j can't be the same, because we need to ignore the same number that we took in the first loop. So we need to check if I not equals to j and nums I means the number in the first iteration. So number in the first loop. So it means 2, 7, 11, 15 likewise. And then we check with nums I plus nums j. Nums j means the numbers except the number that we took in the first loop. So in this case, let's say if we take this case, this scenario, then nums I is 2 and the nums j is 7, 11 and 15. So when j equals 0, it's 7. When j equals 2, it's 11. When j equals 3, it's 50. So you know indexes are, this is a zeroth index array. So the first index of the first number is 0 and second one is 1, 2, 3. So uh, let's say if we take this one, then the nums I is 7, and the when j equals 0, nums I is 2, nums I is when j equals sorry, when j equals 0, nums j is 2, when j equals 2, nums j is 11, when j equals 3, nums j is 50. So in this case, let me use another color. In this case, I equals 0 and j equals 1 in 7, and j, if when j equals 2 it's 11, when j equals 3 it's 50. In this case, I equals 1, and when j equals 0 it's 2, when j equals 2 it's 11, when j equals 3 it's 50. In this case, I equals 2. When j equals 0, it's 2. When j equals 1, it's 7. When j equals 3, it's 50. So we check whether the nums I plus nums j equals given target number. If it so let's say both of these conditions are passed, then we just need to return I and j. So we just need to return I and j. Let me take one of these and walk you through this loop and show how it works. So let's say uh, in the first iteration, in the first iteration, uh, when I equals 0, nums I is 2. Then we so we first we come to this line, then I equals 0, and the n is 1 2 3 4. Let me write it down here. N is 4 because the length of the array is 4, and when I is 0, nums I is 2. Then we go inside this loop and check. Then we go inside this loop. So when j equals 0, nums j is 7. Then we check. So then we come to this line, and when j equals 0, nums j is not 7, nums j is 2, because the 0th index number is 2. So then we go to this condition, this if statement. In this if statement, we first we check whether I doesn't equal to j. So when I is 0 and j is 0, this condition fail, fails because the I and both I and j is the same. So then this it doesn't come to this line because this condition uh, is getting failed. And now we go back to here, and j increased by 1. So now j is 1, and now nums j is 7 because the number in the index 1 is 7. Now we come to this line again, and we check whether I does not equal to j. Now I does not equal to j because I is 0 and j is 1. Then this condition is getting passed, and then we check the other condition. The other condition is whether nums I plus nums j equals target number. So now nums I is 2 and the nums j is 7 and the target number is 9. So this 2 plus 7 is 9. Then this condition is also passed as well. So now program comes to this line whether we just return the indexes of those two numbers, then program will return uh, I it will return uh, I is now 0 and j is 1. So it will return 0 and 1. So let's say we target, let's say target number is, say target number is 18. So if we take the target number as 18, then you can see uh, this condition is getting failed because uh, 2 plus 7 does not equal to 18. So now program does not come to this line, it goes again here. Now it increase j by 1 again. Now j is 2 and nums j is 11. Now we check again whether I does not equal to j. It doesn't because I is 0 and j is 2 and this is getting passed, and then we check again this one whether nums I and nums j uh, adds up to given target number. So now nums I is 2 and nums j is 11. 11 plus 2 does not equal to 18. So it uh, go back to this line again. And then iterate j by 1 again. Now j is 3 and nums j is 50. So again it checks uh, whether the I doesn't equal to j. So I is 0, j is 3, so it doesn't equal. So this is passed and it goes to this line and check whether nums I plus nums j is j equals to target number. So now nums I is 2 and nums j is 15. 15 plus 2 does not equal to 18. So now program comes to this line again and increase j by 1. So now j is 4. So here there is another condition whether where we check j must be less than the length of the array. Length of the array is 4. Now j is 4 as well. So this condition is getting failed because j is 4 and n is 4 as well. So then program comes to this line again. So it comes out from this inside loop and go back to the main loop. So in the main loop, now it increase I by 1. Now I is 1 and nums I is now 7. So then it come back to this line and uh, go through this loop. So first in the first iteration j is 0 and nums j is 2. Nums j is 2. It checks whether I doesn't equal to j. It doesn't because I is 1 and j is 0. So this is passed. And then it checks whether the nums I plus num j is 18. So now nums I is 7 and nums j is 2. So 7 plus 2 is 9. So it doesn't equal to 18. So it go back. So this is getting failed. Then it go back to this line and increase j by 1 again. So now in this iteration, nums j is 7. So then program comes to this line and check whether I doesn't equal to j. Now I is 1 and j is 1 as well. So this is getting failed. So it go back to this. So this if statement uh, is getting failed. So it go back to the this line again. So and it increase j by 1 again. Now nums j is 11. Then we check again whether I doesn't equal to j. So it doesn't because I is 1 and j is 2. So this is correct. And then we check whether nums I plus nums j equals a given target number. So now nums I is 7 and nums j is 11. So 7 plus 11 is 18 and the given target number is 18 as well. So given target number is 18 as well. So this this is true as well. So both conditions are passed. Now we just return the indexes of those two numbers. So in so first index is 1 and the second index is 2. So that's how the brute force method works. So now let's check the time complexity of this solution. So here we have one. So in the time complexity, it doesn't mean the time on the clock. It means the how many operations that we need to run in a given algorithm. So here we have two loops. So in here we need to assign a value. So here there is one operation and there is another operation here and another operations here. So there is three operations here. And then so in simpler way I will say it like this, but we can go deep in this time complexity thing. So but for now I will just ignore the number of operations here. So I will just tell you what the time complexity of this solution. So this loop runs n times because it go through all the numbers of this array in the worst case scenario. So we only talk about the worst case scenario uh, here. So in the worst case, let's say first number that adds up to the target number is the last number. Then we have to go through all these numbers to uh, check. I think it should be I think this loop runs maximum n minus 1 because let's say when we come to the last number, we already we have already checked it with the other numbers. So to yeah, yes. So this loop should only run n minus 1, I guess. Yeah, yeah. In the worst case, it runs n minus 1 times. This yeah, n minus 1. And this loop this loop runs n minus 1 for each of these, each one of the each one of the iterations of the main loop. So it means n minus 1 times n minus 1. So that means n squared. So n minus 1 squared, n squared minus 2n plus 1. So in the time complexity, we only take the highest degree of the uh, highest degree of this equation. So it means O n squared. So we call this big O notation. So in time complexity, there are a couple of different notations called like theta, omega, and big O. So for the worst case scenario, we take big O. So time complexity of this brute force method is O n squared. Now let's check the uh, second method that we can use. The second method we can use is, so this is the thought process for the second method. Uh, let's say we have the given number array and the target number. So, so uh, this thought process here is adding up two numbers. So we just need to check whether the adding up two numbers. So we just need to check whether which two numbers adds up to the given target number. We can write it in a separate way. Let's say if we subtract one of these numbers from the given target number, then we get the difference between this number and the target number. Let's say if we take 2, then the difference between target number and 2 is 2 minus 9 minus 2 is 7. So we can check which if any of if let's say if any of the rest of the number is 7, then this number plus that number should match to the given target number. Uh, but the issue here is, let's say uh, we take 2 and we get difference as 7. Then we move to 7. Let's say let's reorder this thing. So let's say it's 2, 11, 7 and 15. So let's say second number is 11. So when we move to 11, now we lose the track of the difference of the previous number. So we need to keep track of the what's the difference between previous number as well. So let's say now the difference is now the number is 11, and now the difference is 9 minus 11 is minus 2. So now we need to keep track of both of these differences. So the issue here is how we are going to do that. So the easiest way that we can do is to keep track of all these differences is to have to having a map. So we take a map and store each of these difference and the index of these numbers. So why we need to store the index is because at the end, uh, so as the output we need to return the index, so we need to keep track of the index of the number and the difference. So we can take a map and store it as key value pairs. So we take the difference as the key and the index of that number as the value. So uh, difference between 9 and 2 is 7. So we store 7 as the key and index of the 2 is 0. And in this case, difference is minus 2 and uh, so here we can make it little easy. No, okay, so if we, so no, that's fine. Okay, so yeah. So let's say, so in this case, difference is minus 2 and the index is 1. So in this array, uh, index of the 11 is 1. And then when we move to 7, uh, 9 minus 7 is 2 and difference is 2 and the uh, index of 7 is 2. And when we move to 15, 9 minus 15 is minus 6. So the key is minus 6 and the index of 15 is 3. So now we have this map. So what we need to check is, so we iterate through this loop and check whether we already have a key with the given number. That means in the index of that, the value of that key is the index. So index, the number that match with this index plus the number that we have right now should add up to the given target number. So let's say we have 2. So difference between 2 and 9 is 7 and the index of 2 is 0. Now let's say we iterate through this loop and come to 7. So now first we check whether there is a existing key in this map with in this map which is equals to the number we have right now. So number that we have right now is 7. So here we already have a mapping with the key as 7. So that means 7 plus the index, the value of this key is 2, so 0. So number in the 0th index is 2. So that means 2 plus 7 should be, should adds up to the given target number. So this is the thought process of the second solution. So what we so I will write a pseudo code for this as well. So let's say we take a let's say unordered map in C++ with so both of these key value and key are this are integers. So we can write it as like this, int, which means both are integers. And let's say say this is I will say diff map, and then we loop through the array we have. I is 0 and I less than length of the array and I plus plus. Now, what we have to do is first we need to check if nums I means the uh, number in that given ith index, number in the ith index uh, exists as the key in this unordered map. So so in C++ we can do this diff map dot contains, so contains nums I. So if that's the case, then we know nums I plus the number with the value of this key should adds up to the given target number. So then we just return, we takes the we take the value in this key, which means we can just take it as diff map diff map nums I. So that's the key, and then the index of the other number is just I. So which means this in this case this is, if we take this one, this is 0 and this is 1. So let's say this doesn't there isn't uh, an existing key with the given number. So then if else, then we just take the difference and uh, add it to the this map. So we just so in C++ we can, there's a method called mplace. So we just what uh, what does mplace do is it just insert an element directly inside the map. So here the uh, key is the difference between the target number and the number in this ith index. So that means target minus nums I, and the value is the index of the number, that means I. So this is the all that we have, that we should do. uh, yeah, so yeah, this is the code that we need. So I will walk you through this code and show you how it works. So in the first iteration, I equals 0. I equals 0. And in the map, we don't have anything. I will write down the map like this here. So we don't have anything. And so let me write down the nums I write the number array here. So number array is I will reorder it like this. So this is the number array we have, and the target number is 9. So in the first iteration, I is 0, and then we check whether the this is the map, whether there is a key. Let me write down the nums I as well. So nums I is in the first iteration, I is 0 and nums I is 2. Then we check whether there is an existing key value pair with the key as the key as 2. So in the first iteration, map is empty, so there isn't any key value pairs. So then it goes to this else statement. So this is getting failed. Then it goes to this else statement and store the difference between 9 and 2 is 7, and the index of 2 is 0. So it store key as 7 and value as index of the 2 is 0. Now it go back to this line and increase I by 1, and uh, now I is 1 and nums I is uh, 11. Now program comes to this line and check whether there is an existing key value pair with the key as 11. So there isn't one. The only one is this one. So uh, key of that key value pair is 7. So this statement getting failed and program go goes to this else statement. And then now difference between 9 and 11 is minus 2. So now it stores another key value pair. A key uh, key is the difference, which is minus 2, and the value of 11 is 1. So sorry, index of 11 is 1. uh, Now it go back here and check uh, whether now it go back here and increase I by 1. Now I is 2. Now nums I is 7. And now when program comes to this line and check whether there is an existing key value pair with the key as 7, now we can see there is an existing key value pair with key as 7. So this statement is getting passed. Now program comes to this line. So now it just return value of this key value pair is 0, 0, and the index of the 7, the other number is 7, index of the 7 is 2. So this is the result that we get. So I reorder the original array that we had to like go through a couple of iterations. So if 7 was here like the original one, then it will return 0 and 1. So I think you uh, have an idea about how it works. So in this solution, in the worst case scenario, let's say we had to go through until the very last number, then this loop runs n times. So let's say if the length of the array is n, then this loop runs n times. In the worst case scenario, uh, this is um, this is a one operation, and this one, and this is also one. So it runs n times. In worst case scenario, time complexity is O n. Okay, so now let's move to the code and write both of these solutions.
Okay, so now we are going to code the solutions that we discussed. So the first one is the brute force method. So in the brute force method that we talk, we just need to for loop. So first I take the length of the given uh, array, and then I write the first loop as I equals 0, equals 0, I less than n, and I plus plus. And then I write another loop inside the main loop. I take j here, j as 0 and j less than n and j plus plus. And the statement that we have is, if condition that we have is I should not equal to j, and nums I plus nums j equal to the target number. If that's the case, then we just return I comma j. So if there isn't a solution, we just return an empty array. So now if we run this, so, so if we run this, you can uh, see all the tests are getting passed. Now let's say we submit this one. So here you can see the solution, and so you can see it takes 215 milliseconds. And I can't really remember there's a way to check the time complexity of this one. Let me see. I can't remember where it is. So there's a way you can check the time complexity of the worst case scenario. I'm not quite sure where it is. So let's just move to the second solution. The second one is the using a unordered map. So we take an unordered map. Uh, in the future, we will talk about what is an unordered map and how it works in C++. We will talk those things in the future. I will name this map as diff map, uh, and then we define a variable length of the array. So then we take for loop equals 0, I less than n plus plus. Then first thing that we check is whether there is an existing key value pair with key as the number in this iteration. So for that take we take the map and we take the contains method and check whether the nums I key is already there. If that's the case, then we just uh, return an array. First index of the array is the value of this key value pair. We can take that value as diff map uh, nums I, and the second uh, value of the array is the index of the current number, which is I. If this doesn't getting passed, which means there isn't an existing key value pair with the key as the number that we have right now. If that's the case, in the else statement, we just add the difference between the current number and the target number as the key and the index of the current number as the value. So for that, we can use emplace method. Key is target minus nums I, and the value is index of the current number. And if there aren't any matches, then we just return an empty array. Okay, let's submit this solution. So it just only took 3 milliseconds. In the previous example, it took in the previous solution, it took 215 milliseconds. So that's the two solutions that we discussed for this particular question. Uh, there are you can check what are the other solutions we can use for this one in this solutions tab. So there are other solutions that people submitted. Go through these ones as well. You will get you reading someone else code is also a good thing to do because you can understand a lot of things there. So if we check this solution, it uses Java, and you can see it uses the same logic that we used here. It uses hash map. So go through these solutions as well to check other people's solutions and read their code and take a better understanding about those solutions as well. So that's about it for today. So and let's catch up in the in next video with another LeetCode problem. See you guys. Peace out.